Well, hello, this is Mr. Precella. We're going to continue working on that review.
So we're picking up on number 12. This is the Math 13-14 final exam review. And they've given us a problem. F of x equals 3x squared plus 4x plus 3, and they're asking us to find the difference quotient, f of x plus h, minus f of x all over h. And as I recall it, we would split this into 3 steps. Even though they may not ask us to split into 3 steps, what we would do is we'd first of all find f of x plus h. Then we would subtract off the original terms, and then the last thing we do is divide every term by h, every remaining term by h. But we'd make it split into 3 parts. We'd find f of x plus h. This is usually the longest part. So that says go to your function f, and wherever you see an x, what are you going to replace it with? The x plus h. Good. So we're replacing each x with x plus h. And we have to remove the parentheses. Well, we're going to have to remember how to square x plus h. It's not just x squared plus h squared. How do we square a sum? A sum or a difference. How do we square a sum or difference? Okay, we'd write it twice. That's saying you have x plus h times x plus h. So FOIL that out. FOILing out x plus h times x plus h. X times x is x squared plus x times h is xh. I'm going to write it in alphabetical order. If I have terms with 2 different letters in them, I write them in alphabetical order. You'll see why in a minute. X times h, I'm writing as hx plus enter. You see, if we had left this as an xh and that as an hx, you might have not recognized them as like terms. By writing them in alphabetical order, you spot that we have 2 like terms here. What's the last term? H times h is h squared. So we have x squared plus hx plus hx is 2hx plus h squared. And so we've just squared the x plus h. We got x squared plus 2hx plus h squared. We have something else sitting there though. What is it? The 3. Distribute through the 3. Distributing the 3, what are we going to get? 3x squared plus 6hx plus. Okay, good. Now we have that 4 times x plus h. What's that going to give us? Okay. Plus 4h. And we still have what stuck on there? That plus 3. Notice there are no like terms to combine here. So the first thing, question, where did I get the 6? I took the 3. Here's x plus h times x plus h. I distributed the 3. 3x squared. 3 times 2hx gives me the 6hx. 3 times h squared gives me the 3h squared. And there are no like terms to combine. So we found f of x plus h. The next thing we would do is simplify that entire numerator. F of x plus h minus f of x. That says take f of x plus h and subtract off the original terms. If you understand what they're asking for, you can get this step's answer without showing any work. You take what we just found and take away the original terms. Which terms are about to drop off? The 3x squared minus 3x squared, I agree. What else? 4x minus 4x. Anything else? The last 3 minus 3. Here's a hint. The only terms that remain should be containing the letter h. Anything that doesn't have an h should subtract off at that point. So you have 6hx plus 3h squared plus the 4h. Then we need to divide by h. The quickest way to do that division by h is to divide each term by h. So I'm going to go over h, over h, over h. I'll get us started. The h cancels there, leaving us just a 6x plus. Okay, so you cancel one h above and below, so you still have a 1h remaining, so 3h plus. So the difference quotient is 6x plus 3h plus 4. If you have to take a calculus class, that difference quotient is an important part of the definition of derivative. And so at that point, you'd have to start worrying about what happens as h gets closer and closer to 0. We don't have to worry about that. All we need is 6x plus 3h plus 4. So coming back over here, 6x plus 3h plus 4. Any questions there? No? Okay. Moving on, number 13. Factor f of x into linear factors given that k is a 0 of f of x. This is number 13. Let me write the problem down. F of x is equal to 3x cubed plus 8x squared minus 15x plus 4, and they give us a 0. K equals 1 is a 0. K equals 1 is a 0. I'm going to make sure I don't miscopy. 3x squared plus 8x minus 15 plus 4. We have a method of factoring higher order polynomials, but it requires that we know a 0. Remember, a 0 is a number that can be plugged in for x to make the y value equal 0. If we went through and we plugged a 1 in for every one of those places where the x is, it would reduce to 0. That's what they mean by k is a 0. We had a little division process that we would use. Who remembers the name of that process? Synthetic division. But you don't remember that?
I don't remember the name, but I know what to do with it.
Okay, that's more important. Okay, remembering what to do with it is more important than remembering the name. So you make your
like a kind of a table. So you start with x to the third power.
Okay.
X squared.
Yeah, we start with the largest power of x, so I put the little column headings, x, and then a constant.
And then it'd be 3, 8.
So
negative 15, and 4.
So you're putting in the coefficients, 3, 8. The coefficient of x is negative 15. The constant is a positive 4. Well, this isn't very interesting. That k value of 1, it would be better if it were some number other than 1. We drop down that 3 to get started, and then we go
Multiply by 1.
3 times 1 is a positive 3. 8 plus 3 gives me a plus 3. Okay, a positive 11. Then we repeat. Positive 11 times 1 is a positive 11. Negative 15 plus 11 gives us a negative 4. Negative 4 times 1 is a negative 4. 4 minus 4 gives me a constant of 0. You started off with an x cubed. You divided it by a factor of x. So what's the largest exponent going to be in this quotient? X squared. It decreases by power 1. So we have a 3x squared plus 11x minus 4. So we now know f of x is equal to, what was the factor associated with this 0? Remember, it's something that you can plug in 1 and make the thing equal 0. So it's going to be x minus 1. Remember? What the factor, what you see in the factor is exactly the opposite of the 0. That 0 was a positive 1, so you have x minus 1 as the first factor. So the divisor times the quotient, 3x squared plus 11x minus 4, will give us the dividend, 3x cubed plus 8x squared minus 15x plus 4. The instructions say to factor. Now we have it factored. This is written as a product. We have a linear times a quadratic, but remember the instructions say factor it into linear factors. That means that this x squared expression, we should be able to factor them so that it just contains x. Well, we know how to factor a trinomial. We know how to do that.
3x minus 1 and x plus 4.
Okay, so we're writing our two sets of parentheses. X cubed, you say that's x times 3x. And Caitlin, I think I heard you say it. What did you say?
Plus 4 and minus 1.
So the plus 4 goes with the x or the 3? The plus 4 and the minus 1. I agree. Avoid that pitfall of 2 times 2. I think that would be the most common thing to try.
You're so good at factoring, Caitlin. Before this class, before this semester, had you been doing a lot of factoring? No? Oh, okay.
So you just patting yourself on the back, Tony?
No, I'm patting her on the back.
Oh, okay, good.
Yeah.
And y'all want me to FOIL this out to confirm that it gives me back 3x squared plus 11x minus 4? Do y'all see that? That's just confirming. X times 3x is 3x squared. Outer. Negative 1x. Inner. Last. So we have a 3x squared. Negative 1x plus 12x. Sure enough, that's a plus 11x.
All you're doing is
and a
checking
minus
and
4.
making sure you factored it correct.
Yes, it was correct. I was making sure Caitlin factored it correct.
I'd already done that in my head.
I had two, Tony.
Oh,
Okay.
What's happening here?
There.
So x minus 1, x plus 4, 3x.
X minus 1 times x plus 4 times 3x minus 1.
You're saying times, but I'm just writing parentheses.
That's what those parentheses mean.
Yes.
and realize the order doesn't matter. You could have typed x plus 4 times x minus 1 times 3x minus 1. As long as you have the same 3 sets of parentheses with the same step in them, you should get it counted correctly. Oh, an exponential equation. Number 14. Let me write the equation. Solve the equation. E to the 8x minus 1 is equal to e to the 6th all raised to the x. And let me, there.
Get down.
We had two methods of solving exponential equations. We had the same base method and we had the logarithmic method. And I think here we can use the same base. Remember that e is not a variable. That's representing the natural exponential, an irrational number, approximately 2.718. The exact value doesn't matter. You're not going to write e as a power of anything other than e. So fortunately we have bases of e on the same side. Well, we have a power raised to a power. What do we have to do with the power raised to a power? So that's going to give us e to the 8x minus 1 is equal to e to the 6x. Power raised to a power, you multiply 6 times x. And once you have the same base on both sides without any parentheses, what can you do? Okay, so you drop the base, set the exponents equal. And what do y'all want to do to solve this? Minus the 6x, minus 6x and minus 6x, and add the 1. So we have an 8x minus 6x, that's a 2x equals 1. Dividing both sides by 2, we get a final answer of 1/2. Any questions there?
Will we be going over all of them today?
No.
I think we'll, no.
For the most part, before that, I want to stay here though.
Okay.
I like reviews.
I wanted to do at least 10 of them. And,
Okay, number 15.
This is some nice number theory. It's going to take a little thought.
Solve the equation 16 to the 3x minus 6 is equal to 64 to the x plus 3. It's another exponential equation. Remember, exponential equations are equations where the variable is part of the exponent. So, can we get a common base? What can we use as a common base?
Can we?
Can we?
Well, yeah, the 64 divided by 16 is, you can make this, I don't.
16 to what power gives us 64? 16 to the first is 16. 16 squared is?
Yeah, I was saying 16 to the 4th power.
Oh.
No, 16 to the fourth
Oh,
is, wait, 16 to the 4th power. Is that going to give us 64? It's going to give us something of a very large number. So,
Yeah. So let's look at the smaller base and ask, is there some fact from the multiplication table?
I heard Kristen say it.
Oh.
Yeah, I don't think you can write 16 as a power of 8. No.
8 squared would give us 64, but that wouldn't get...
8 to the first, does that give us 16?
What fact from the multiplication? Do you start with the smaller number?
16. Write it as an exponent. You want to write 16 using an exponent.
What number squared would give you 16?
Okay, 16 is the same thing as 4 squared. 16 is the same thing as 4 squared. And how do we write 64 as a power of 4? Maybe 4 cubed?
I multiply 3 4s together. Is that going to give me 6?
Mm-hmm.
I'll see how we're. And notice how we started with a smaller base. You might look at 64 and say, wait, 8 squared. Yeah, but you can't rewrite 16 as 8 to a power.
But then you just multiply those with.
Okay, so power raised to power, so we multiply here. What's that going to give us? 6x. Keep going. Okay, distributing the 2 over the 3x minus 6, that gives us 6x minus 12. And then distributing the 3 there, you get a 3x plus 9. And then, once we have the same base on both sides, we drop the bases, set the exponents equal. What do y'all think I'll do to solve this? Subtract 3x. And add 12. I don't know why I'm showing this stuff now. I haven't been showing it. I haven't been doing that all class, but I started on the last problem. 6x minus 3x gives me 3x. 9 plus 12 is, and then dividing by 3, we get x equals 7 for our final answer.
You said that was a long one.
No, it just took a lot of thought because you got to figure out that common base.
I always mix that up. I like the reverse.
We're going to do 2 more problems.
Number 16. The square root of 2 to the x plus 9 is equal to 16 to the x. Square root of 2 to the x. It's another exponential equation. Notice how the exponent appears the variable appears in the exponent position. That's what makes it exponential. And let's see, can we get a common base here? I had a trick. I remember sitting here going through this material when it was brand new, and I said, when you see a square or a radical associated with an exponential or logarithmic expression, you have to add this trick to your bag of tricks. What do we do when we see a radical? Okay, I'd write it as an exponent of 1/2. Is that what you were saying? A square root is the same thing as an exponent of 1/2. Remember we said that the square root of n is the same thing as n to the 1/2, and I should have used a for anything. The square root of a is the same thing as a to the 1/2, and in general the nth root of a is equal to a to the 1 over n. And we used that idea a lot when we were expanding and condensing logarithms in future homework assignments. Square root, that's the same thing as an exponent of 1/2. Now 2 is a prime number. You're not going to change 2. So you better be able to use a 2 over here. 2 to what power will equal 16?
Don't say 8.
2 to the 4th power. Okay.
4
2 to the 4th. Where's your calculator?
Is 2 to the 4th going to be 16? Yeah, 2 to the 4th is like 4 times 4, isn't it?
And then what am I going to do? Now that we know that 2 is the common base that we're looking for, what will we do next?
Yeah.
Okay, multiply.
Basically, you're doing exactly what you did right here, just
Getting rid of the
you have a
exponent
fraction
and the
x.
parentheses by distributing. 1/2 times x plus 9 is plus,
Would you just do 4.5 or like?
I'd write it as 9 over 2. 1/2 times 9 is 9 over 2. Equals here, 4 times x is 4x. And then what can we do?
Drop the 2, sorry.
Drop the 2, set the exponents equal. 1/2 x plus 9 over 2 is equal to 4x. What can we do? Well, let me ask you, what do you think I would do? What do you think I'm going to do? Get rid of the fractions by multiplying through by 2. How many times am I going to have to multiply by 2? Every one of those terms, even the thing that doesn't have a 2. You distribute a 2 over both sides. There, there, and there. 2 times 1/2 x gives me, okay, just 1x, the 2's cancel. 9/2 times 2 gives me, what's going to cancel?
Okay, so 9.
Okay, so the 2's cancel, and that leaves us a 9. 2 times 4x,
It would be
8x. There's no fraction here, so there's nothing to cancel. I think in the past we would go through 2, 2, 2, but we're advanced enough now just to distribute the 2. I'm going to get this x over here by doing what? Okay, 8x minus 1x gives me 7x equals 9. And then divide by 7 to give us x equals 9 over 7. Nine over 7 for my for my final answer.
Always like I put that calculator there.
How did I get what?
How did you get 9 over 7? I got 1.
I subtracted x from both sides.
That's what I did.
8x minus 1x gives me a 7x.
I got it.
Oh, did you
Okay.
get a 9x?
Yeah,
and 9
I
over
said
9?
subtract x, but I just went straight in that like, oh yeah, 9x, perfect. Like, perfect answer.
Number 17. Find the logarithm using the change of base formula. Number 17. Log base 7 of 0.05. Those of you in the peanut gallery, wave your hands in the air. They don't detect that anyone's over there. That's why the lights are going off. Or stand up and walk around. Oh, okay. Oh, yeah. Okay. Well, let's see. Oh, and that's being recorded, isn't it? Okay, find the logarithm using the change of base formula. Let me switch over to my paper. Let me pull up my calculator. And let me clear off that calculator also. The change of base formula says that you can change any sort of logarithm of any base to either log or ln, and by writing it as a fraction. What do y'all want to do? Y'all want to use ln on your calculator or common logarithms log? Oh, I think we like ln better.
So why are you giving them a choice?
Well, it's like when I give you a choice on where we're going to go out to eat.
Oh.
You get to You can choose, and if you choose it's the wrong place, you can choose again. You can choose again. Okay, so it's a fraction. Okay, Caitlin, you use LOG, and I'm going to use LN, and we'll see if we get the same answer.
Same final answer.
Same final
The
answer.
intermediate answers might not be exactly the
They
same.
won't be the same, but the final answer is
long
the
as you-
natural log. You put the argument, the thing that's written up on top. That's what goes on top here. The old base is what goes on bottom.
The number that's written lower, that
The what?
subscript, goes
That's what-
on the bottom.
So we're going to punch in, and be careful if your calculator opens parentheses the way my calculator does. That's LN.
Close it. Why don't you put in the red parentheses where it's going to
Okay.
need to be?
I'm going to put in parentheses, red. When we press that LN, the calculator's opening a parenthesis, we're going to have to close it. Likewise down here in the denominator, when you press LN, it's going to open a parenthesis, we need to close it.
Now,
And
I'll just demonstrate. If we chosen to use LOG, as long as we don't mix it, you'll get the same. By that I mean don't use LOG on the top and LN on the bottom. And as long as you close those parentheses.
did we get the same thing? It certainly looks like we did.
And how are we
And that's-
told to round it?
I don't know.
4 decimal places.
So that's a negative 1.5395. I agree.
Yep.
Usual rules for rounding. Negative
Digit
1
after the
point.
5 is a 0, so just drop it. If it had digit after the 5 had been a 5 or bigger, you would round it up. So
Negative 1.539.
Negative 1.5395. Okay. And I'm pretty sure the next problem is not another change of base, but if it is, we'll do, okay, this will be a good spot to start on Wednesday, our last day of class.
Okay. I'm going to make a note here for my reference. This is end of video 3. Remember we did the first video on Wednesday, working problems 1 through 5. Then the second video went 6 through 11, and now 12 through 7. 1 through 5, 6 through 11, and then 12 through 17. Okay. We'll get these videos up. Oh, you can stop recording. We'll finish this review on Wednesday.
Goodbye.